Record. Dismiss. So to start off, do you guys know what GitHub is and Git? Okay. Now to recap, with Git, Git allows you to save commits, save those changes that you've made to a repository, a place that you've set up when it comes to creating a project, creating something like that. So first, to start off, we're going to work with GitHub, the website. We're going to create an initial repository there, and then I'm going to show you guys how to initialize a repository on your computer through the terminal, as well as what you're going to be doing with the actual GUI interface. So you're going to learn both of those. This is just the introduction to this type of topic. So you click New to create your repository. You're going to give it a name. This one is going to be Git_workshop. Now you can do a description. When it comes to public or private, that simply means if you do private, you have a key that you have to create and then use as your password. So you have to save that key. If you don't save that key, it's lost. They generate it, and that's the only way you have access to this repository. For our purposes, we're just going to make it public, and we're going to create. So now that we've created this, you can see that it gives you some examples on how to create it. You can just literally copy this and git clone, and then you're cloning this empty repository. But we are actually going to go on over here. This is our terminal. Are you able to read that? Let me.
Okay, that's a lot better. I was going to say like the colors.
So we're going to create a direct. So we're going to make dir Git_workshop. Now you don't have to title it the same thing. It's just going to basically let you know that this is what we're working with. So we're going to cd into Git workshop, change directory, clear the screen, else we could see cd Git workshop. There we go. Now we're in the Git workshop. So to initialize a repository, first we're going to do git init. And now if you do a dot, it's just going to initialize with that directory title. So as you can see, we're getting a bunch of information on our screen. I'm going to minus out so you can read it all. It's essentially just saying that when you initialize a repository, its name is automatically the branch of master. You can change that globally. Some people do, some people don't, but that's just what it is default. If we wanted to change that name, we can do git branch -m main. So now the name of our branch is called main and no longer master. So once we have this set up, we can see that then we move on to, like, if we want to have a Readme file with your GitHub page itself, your Readme file will appear down here, and I'll show you what that looks like just now. So if we do touch Readme dot, we have to do caps. So now we have a Readme file created. When you want to add things to GitHub or Git specifically, you want to be able to stage files. I can't see you over there. He doesn't matter because he understands all of this. But when you want to make sure that you're committing the correct files or make sure you're making a commitment, and the commitment is simply you have all this stuff that you did in your directory and you want to save this change as a whole, you make a commit. Commits can be done discreetly. So like after you do small changes, you make a commit, because at the very end, you're able to group different commits together. For the example of if you're creating a large program, anytime you're making a function that deals with another function, make a commit after that, because you don't want to lose that. You don't want to lose anything that you're creating. So make the commit even if you don't think you need to. It's better to have more than less, because if you have less, you're going to lose something inevitably. And so to basically go through the notes, no, that's not going to let us do anything. Okay, aren't you going to let me zoom in? There we go. So once you make this git init, then you can add the readme file and you can commit. So this initial commit is basically your starting point. It's what allows you to then continue on. You don't necessarily have to do a first commit. You can just start working and then commit after that, but it's good to have that starting point. So for that, let me zoom out. Here we go. We can do git commit, if I spell it correct, -m for message. So you're basically giving your commit a title. So in this case, first commit.
What would happen if I didn't use the
-m would just, you would no longer, it would give a default title. It wouldn't give you anything. So if we did, you're still going to commit. Now, we didn't add any files. So Git Add basically allows you to Git Add dot. The dot basically means add everything inside your current working directory. So if you have the README file, if you have code, other directories inside of this, it's going to add it all to your stage, which then is what's committed. So Git Add, if we do Git status, so if we do Git status, you can see that now we added a new file, readme.md. So let's clear the console. And so git commit -m for message, first commit. Now we can see one file changed, insertions, deletions, nothing was done. We just staged this file, we committed it. So when it comes time to pushing this stuff to your main repo up here, because now we're actually going to have code in here, it's no longer just going to be empty. We want to make sure that we're using this address that they give us. So we can do Git Remote Add Origin. And origin is simply the name that you give it. You can give it any other name. You could say Git Add Duck if you wanted to. It's the name that you give it. It'll still work. Still works. So now we can do git push origin main. And now it's going to push what we just did, which was only the README. So we scroll on over here, we refresh the page, and we can see that there's a README file, but there's nothing inside of it. And that's pretty much how you change the name of the branch that you're currently on. Now you can do push U, which is basically just set upstream if you wanted to. But we kind of did that with setting up the remote add with origin and the file and the address of where we're sending it. So another main part of GitHub, or Git, sorry, not GitHub. GitHub is the website, is when you're working with a team. That's where it becomes very crucial with pull requests and all of that stuff. Now, with Git, you have something called branches. So you can work on your main commit line now, but that's not good to work on that, because if you have, say you're working on a small portion of the project, you have him working on another portion, but you don't want to mess up anything on his end and he doesn't want to mess up anything on your end. You can both branch off from that main line and work separately. And then when you have things you want to save, push up, you can push up. But when you want to put everything together again, you have to do a pull request. And how that's done is, first, we're going to talk about creating a new branch. So to create a new branch and to switch to that branch are two different things. You can do them at the same time with git checkout -b, which allows you to create that branch. If you just did git checkout and then specify the branch, it will just switch you to that branch. And we're going to do, give me a branch name. That spelled correctly?
Yes.
Just making sure. So now we're on cheese. See it right there. So we're gonna touch and we're gonna create bread and ham. Thank you. Yes. Got to keep with the theme. So we can see that inside here, now we have bread and ham. Now, if we wanted to echo some text, so we'll echo sandwich. To bread. So now bread is sandwich. If I cat, you'll see that I'm going to get an error because I'm using fish and it doesn't like the word cat. So inside of bread, we have sandwich. Now we can, yes, I know. So next up, we're going to Git Add. Git Add, remember, puts everything onto the stage, and then we can commit. Now you can see the plus sign because we've added stuff. Following Git Add, we can actually check what we've added as well as what branch we're on with Git status. So we can see we've added bread, ham. Now, a good habit to get into before you push up or do a pull request, you want to git fetch. And that's basically going to bring down anything that's up there to you first. So that way you're up to date before you start pushing stuff over there. Because you don't want to push something that isn't there or push something that is there, but it's been changed and altered already. And so now you make your commit. And now we're going to be changed. Now we can do added bread and ham. Your commit messages always want to be relevant to what you're doing. You don't want to have a random commit message because it's a timeline of all of the stuff that you've done to your project. If you have a lot of commit messages, each one is detailing the small portion that you've changed. You can look back and you can, if you have to revert to a specific commit, you're able to go back to that specific point in time. So now we've committed these two, git push origin cheese or Oregon cheese. So now you can see here, create a pull request. So right now, all we did was push our information up to GitHub or Git as a general, and we can view it on GitHub. So you can see that the GitHub is showing that we can do a pull request. As I mentioned, the pull request is now you're simply merging what you did with the main. You don't have to do that after every time. That's mostly what you do at the end of your project, when you're completed your small portion and now you want to work on another portion. So when your section's complete, you do the pull request. When your section is complete, you do the pull request. So that way you're not overly sending every little thing when it's not ready to be sent up. So say your section needs to be completed as a whole. His section, he has small subsections of his main section, and then he could kind of do a little bit more pull requests than you would. So now you compare and pull if you were done with your project. So you have the commit message right there. That's the title. You can add a little bit more comments and information if you wanted to. Create a pull request. Now checking for availability to merge. This branch has no conflicts with the base branch. So say you both coincidentally were editing the same file. And when you pushed it up, his was pushed up before yours. So his was accepted. Then you try to push yours up, but yours is in conflict with what is already there. That's not good. So there's one thing if you're adding something to his information, but say he's adding something, you're changing something, and it can get combobulated. Go.
Is that per file, or does it actually look within files?
It looks within files. So if
I add a line to a program and they add a different line to the same program, that will still be able to be merged.
it can, as long as they're separate lines and it's not overall changing anything that is
For
using
example,
something
imagine
else.
To have written the same named function that does the same exact thing, but have implemented it differently. So the way it would work is when it says there are conflicts, it'll give you a button called See Conflicts, and it'll open up a text editor, and it will separate the two different variants of the same change by showing the name of the commit that did that one change and the other one. And basically, to resolve the conflict, you just delete one of the changes, and you just select whichever one applies better to the piece of code.
But
Yeah.
what if they're different changes, like they're not related, they're in the same file? Like
Then-
If they're not related, they are not going to split.
Yeah. Yeah, if they're not related, they're not going to have a
Did you save
conflict.
The file with both of those changes?
Yes.
Okay.
Because it's kind of like, it's the idea that if he's building a sandcastle and the other person's building a sandcastle, they can both build a tower on the same sandcastle and nothing's going to happen.
Okay.
But if he's building a sandcastle and he comes and takes a big chunk out of his sandcastle, something's going to collapse. And that's because it won't function correctly.
You have the same file and are collaborating
Mhm.
if you're on different branches.
Yeah, as long as you have this same base file and you're not,
Making the same code.
yes.
Okay.
So it's kind of like if he's editing line 5 and he's editing line 10, that's fine.
One thing to note is that where the branch starts is important. If you start a branch, like for example on commit 10, someone else starts a branch on commit 15, you guys all have different variants of the main files. Meaning, if the person who's farther along does a merge, and then the person who is on the earlier branch tries to merge, they're going to have an error called missing data, where the files that they're trying to merge into have a lot more changes than their changes. So it's going to give you the same prompt to like select whether you want to keep the newer changes that you're merging on, or do you want to merge onto the bigger file?
Yeah. Hence why you want to fetch before you start doing anything else. Because normally the person that's farther along and has more changes will push their commit up first, then you will do yours. So that way you're,
Before you commit.
yes. So you want to come, yeah, after you commit, then you fetch, because you can't fetch if you have unstaged commits. I'm going to get to that. So once, okay, it's not important. So pull request was successful because I completed, I said you can do the merge. Now, once you do the merge, you can delete the branch because the branch is technically no longer needed. You can have branches for separate areas, and once you complete that branch, it's kind of gone. The best way I could say it is that you have your commits going like this, and then you have time, commit, time, commit, time, commit. Now a branch goes like this from the last commit, and then you can commit on the branch, commit on the branch. When you're doing the pull request, you are taking your branch and you're putting it back. So now this is over here. You can still kind of show this branch, but if this branch is no longer there, it's kind of overwritten what's right there, if that makes sense.
The branch actually stays forever in the way it organizes documents, meaning if you ever have to revert to a previous change after you broke something, the branch exists. But when you delete the branch in the system, that means you close the branch from adding new commits to it.
So it's kind of like taking the branch away. So now
you don't delete the branch,
marking it inactive is the best way to say it. So now we're done with this. We can delete the branch if we want to. You can also revert back to a change if you didn't mean to do that. Yes.
So does that mean that the main branch is typically just used for pull requests? Like
Yeah.
say you have 5 collaborators, they're all working their own branch. The only changes you'll actually see to the main branch are pull requests from.
Yes and no.
The main
The
branch.
main branch is usually where you would store the master code.
Right.
So it's kind of like the
There are
completed
people
portions.
who will work in the main branch if it's some sort of server configuration, because usually things like that you want to write in the main branch to just get it done and fix it.
So like little things.
Yeah.
Right. So for example, if you're in a big software company, there are going to be like senior devs who are primarily working on the main branch and just making sure everything's working on that branch. Like if you're just changing files on there just to fix them up a little bit. If you're developing new things, you want to branch so that in case it breaks the code, you don't break the main system.
Right.
Yeah.
But you can still do pull requests to other branches. You can merge 2 branches together into one if you have 2 people who are working on the same thing accidentally, and now they can just merge the changes together so that the code base is now complete.
Any other questions so far that either myself or Lev can answer? Okay. So we've gone over the making a pull request. We've gone over how to initialize a repository. Now we're going to go over the actual Git GUI, what exactly that does and how you can use this. This is quite a bit simpler than just what this is. This is a sample. It's actually his project that is on the screen right now. Yes. So you can see how the red is stuff that was deleted, plus signs is stuff that's been added, and any changes made. So if we go to add, because we want to add a new repository, you can clone a repository, you can create a new repository, or you can add an existing repository. I'm going to add in the repository that we just made. So if we go into Git work, we can actually go back one, make sure we click on that, open, add repository. So this is our current repository. We're on branch cheese. We can change to branch main. And can publish the branch, because one of the cool parts about the GUI is that if you didn't initialize a repository already, you can just create it with the GUI. Whereas in the client editor, or client itself, the command line, there we go. With the CLI, I have not found a way where you can just create everything in the CLI without going to GitHub and having to create the repository there so you can then access it.
Because you log into GitHub Desktop, the application itself, it's synced to your account, so it has access to the server storage that your account has access to. So you can directly create new repositories, get other repositories onto your computer quicker. One cool feature it also has is, for example, if you created a folder for a repository, but then you need to move it, or you have different code you want to put on the branch you're currently working on, in GitHub Desktop, there's a way to move the folder of the repository, and it will change whatever code you have in the repository.
Yeah.
Which is sometimes useful if you screw up your folder organization.
So as we know that we already committed stuff, we already pushed stuff up. So when we publish a branch here in the GUI, it's going to let us know that the desktop is unable to push the commits to the branch because there's already stuff over there. So we can instead fetch. What fetching does is it allows us to now see everything that's happened there. So now if we go on over to our, we're going to get, we can go back to, we're not going to go back to cheese. So we'll get branch, checkout branch, -b. And what's another branch name? I like the food theme. So now we're on pizza. So now we can touch. Can someone spell pepperoni? Probably spelled that wrong, but that's okay. Okay, good. Making sure. So now we're on pizza. We have touch pepperoni. As we can see, yes, there's a square, meaning we have an unstaged change. So first, let's go on over to the client, and we can see changed file. We have to add. So we can commit to pizza. And now we're on current branch pizza history. We've created pepperoni. Because it will it automatically gave it a title based on what we've done, and it knows what we've done.
But it does have a limit to the auto names. If you are working inside the file that already exists, a lot of the time it cannot come up with a name because it'll try to name it whatever the function name you're working on, but it's not perfect. So it can give you issues if you don't name it. So it's usually recommended to give it a name. And one thing about GitHub Desktop is, can you go back to the UI? You see how there's a name? That's the summary. That would be like the title of the commit. Then it has a description box. So if you did like a bunch of changes, you can like fully write out what you explained, and that will be saved in like the system for GitHub. And then there are plugins for GitHub that can generate documentation for changes, for tracking what you've changed over time. So like update logs, basically. And you can actually have it automatically update the Readme file. So if it's a public project that you're basically sharing with tons of people, you have a way to show them what has changed over time and what are the new updates and stuff like that. So it's a very useful tool for not having to spend extra time later documenting changes.
Put that up, yeah. Through email? View everything without leaving. There. As Dylan so graciously did, please scan this QR code so you can get attendance.
That's interesting.
I like it. How'd you get it? Perfect.
I know you are. Please tell me you did this in Excel. Damn. Oh.
How?
Probably QR code generator.
Okay, let me know if you done. You got it? You're good? Okay. So now we've made a change to, I made a change to pizza. Well, y'all were talking to show Lev's point. So if we Git Add, we can do that all through the client. We don't, through the GUI, we don't need to do anything here. So now there's changes. You can see the plus sign. This is some text to test the auto naming. So now there's just an update to pepperoni. That's all it's going to say. That's the auto name because they don't know exactly what we did. They're not going to give you any extra information. It's just simply going to say we updated this file. Come to pizza. Now we want to publish this branch. It basically just means you're pushing to the origin. So now let us do a little. And now we are inside of code. We got to go to code. Pizza has recently pushed less than 1 minute ago. You can make a pull request there. So we have cheese. Now we have pizza. And on pizza, we have pepperoni. And this is some text to test the auto naming. Any questions so far? Do you guys think you could accurately do this on your own computers? It's pretty straightforward.
Show them Stash.
Stash, yes. So as we mentioned earlier, when you are, if you have a commit and you say we're working on something. So real quick, we're going to add touch, another name. Another name. There we go. So now that we have some work here. If we wanted to git fetch, it will works. Okay.
It works because you made changes.
Ah, okay.
So basically the idea is if you have two people, more than one person working on a single branch, you're gonna have you're working on some changes, someone else is on their time working on their changes. And for example, they submitted changes to the main branch, for example, and you need to update your main branch, right? You are about to create a new branch, for example. Well, you can't commit changes before you get the previously already sent in changes to the server. But you can't fetch without deleting all the files and changes you've done already. but you can't commit before getting all the new updates. So GitHub Git has a tool called Git Stash. What that does is it does a similar thing of like committing, where it generates like a change list and saves the files, but it hides them. So it doesn't put them onto the tree of changes. It just hides them in your local storage.
Takes the files, puts it in the box, locks the box so your siblings can't get to it until your siblings are gone or they did what they needed to do to your room. Then you can open the box and take your stuff back out.
Interesting analogy. But basically,
But accurate.
yeah, it does work. But stashing, what it does is, if you have, it can be used for a lot of reasons. You are working on some changes and you really don't like what you've done so far, or your code's not working. So you can stash it away so that later when you come back, you can, instead of having to go back fixing your issues, you can redo your stuff or continue working on new stuff. And if you want to go back to the changes you stashed, you just do git stash pop.
So
It puts the stash up, it puts it back into the working directory, so you can continue working on your changes. This allows you to protect your code that you worked on. It allows you to test if something's causing a bug, especially if you do a bunch of commits. That allows you to organize your code more efficiently so that you can track down what's causing the bugs. So you like coded a new function, you're not sure why everything's crashing, you just git stash, see if it works without it. If it does, then you know where the problem lies. The other reason you would stash is, as we said, you can't pull data without saving your files correctly. But you can't commit the files without pulling the new stuff.
you're stuck.
So you just stash your changes, fetch the new information for the repository, and you pop the stash, and then you can commit.
So as I showed here, I tried git stash. Now there's no local changes to be saved. That's because we have not added anything to the status. So now we can do git add. So we've added chocolate sprinkles, ice cream. So now when we do git stash, it's going to save it in this little address right there. So now we can do git stash pop. And now it brings these files back. So that way now we have access to them again. So that's pretty much the main topics discussed today. This page right here is going to be available to you guys. I can send it to you through email, however you want it. But yeah, that's all for today. How do I get to my other page? How do I get to my
Don't know
page?
if I'm gonna remember it all, but, you know,
That's why I have the document. Pretty good one.
always wanted to start learning how GitHub works.